Hello everybody, I'm Alexy Khrabrov, the organizer of SF Spark and Friends, a new meetup about Spark and its ecosystem, such as Kafka, Cassandra, Apache Flink, a new system called Mindata we'll hear about later today. And we're very happy to have here with us Sandy Ryza, who is the senior data scientist at Cloudera and the author of the new book from O'Reilly called Advanced Analytics with Spark, of which we have multiple copies here in the office, and we're very much enjoying it.
Great to hear.
And the topic of Sandy's talk about semantic analysis of 4 million documents with Apache Spark is highly relevant to Nitra, which is a document productivity company. We work with hundreds of millions of PDFs. We want to understand what they're about. So this is the technology we chose to use as well. So welcome, Sandy. It's great to have you here.
Thanks for having me here, Alexy.
So I did some research on you, and Cloudera has a nice blog post entitled "Meeting the Data Scientist," and and we both know Josh Will pretty well. So it's kind of expounding on Josh Will's theory of what a data scientist is a little bit, but that was I think a year ago. So I'm wondering. So it basically kind of reiterates the theory that data scientist is a data janitor, and has also some interesting points. But I'm wondering, after that year at Cloudera, and especially after writing this book, did your initial vision change, or was there some evolution of this, and what it is?
That's a great question. Yeah, I would say that probably, if anything, my vision has been reinforced in that. A lot of my job is doing engagements at different Cloudera customers,
Mm-hmm.
so helping telecom companies get it set up or
Mm-hmm.
whatever people want.
Mm-hmm.
And very rarely does it come down to actually, let's say, applying a machine learning algorithm.
Mm-hmm.
Often people turn to people who are called data scientists to have someone to think about the data, reason about it, and try to sort of do the same common sense stuff that you might use in other spheres. But I don't know, maybe some people feel unconfident in doing that in relation to large data sets.
Mm-hmm.
So yeah, if anything, I would say that data janitor thing is still some huge percent of it, and then another percent of it before you even get to doing math or statistics is just sort of what makes sense here.
Right. Right.
With this data.
I think there is a number floating around that 80% of the data scientist's job is spent managing the data. Do you think
Right.
that's roughly the right ratio?
I think that's roughly the right ratio.
Mm-hmm, mm-hmm. And so, I mean, in my theory, I kind of also have some kind of simple way to summarize what the data scientists are. So I wonder, they're kind of exaggerated, but I will run them by you. So one theory runs that, data scientist, a small data scientist, is a Python programmer who can, sort an array, right? And because typically, I wonder if you agree that most algorithms, most results can be obtained with this algorithm, which is sort, unique, take top 10, right? Which is super easy to do on Unix, right? Because you can pipe these things, right?
Yeah.
And you can, when you do exploratory data analysis, you can very easily. And it's just a question, what are you sorting, right? So once you have something to sort, then it's probably going to be...
You're just trying to get things, in the state that they can be ordered.
That's right. So you do some Schwarz and transform, you make tuples, you sort on some field, and then you get the rest, right? So that's how it usually starts in small data. So the big data scientist is somebody who can sort the array on Hadoop or Spark or something which spans more than one machine. And then, of course, it becomes much, much harder because even getting the array there and sorting it, and it's much harder. So I wonder, if you would agree with this, and kind of, and then kind of the question is, do we have two kinds of data scientists? Because machine learning is a harder and very different thing, and usually it's explained through R, for instance, and statistics, right? So in reality, I noticed that a lot of people who can really properly sort distributed array are different from the people who can reason about, gradient boosting and various optimizers and various machine learning algorithms. And the latter kind of people usually develop in MATLAB, and the top, for instance, vision scientists program in MATLAB, and so they still have to integrate in some way. So I wonder what's your take on this? What do you see at Cloudera? What do you see in inside these things merging? Are they still kind of developing in parallel? What's your view on this?
Yeah, certainly. I mean, I think in general, people who call themselves data scientists, it sort of breaks down to people that come from more of a math or statistics background, and people who come from more programming background. And I think the whole thesis of having like data science as a term at all is like the idea that it's useful for these types of people to get together and for single people to try to gain a little bit of both of these skills.
Mm-hmm.
In many situations, you call the latter group, the computer science group, data engineers.
Mm-hmm.
That's the breakdown that happens to be a lot of companies, but I don't really see that division going away anytime soon.
So, but there are these kind of unicorns who do both, right? I think you're closer to the unicorn.
Right. I mean, the dream is that you're able to build frameworks like Spark, for example, that makes it easy to do both, right? To work with huge data sets, to put things in production, but also to easily leverage whatever knowledge you have about math or statistics in a way that doesn't require coding that up in Java or MapReduce.
Yes. So you're also a contributor to Apache Spark. So a year ago, you described your job as spending half the time with customers and half the time contributing to tools such as Apache Spark.
Mm-hmm.
Is it still the same ratio?
It's a good question. Yeah, I think that in the very recent past, I've moved a little bit away from Spark and a little bit more towards the data science side of the job.
Mm-hmm.
I've been on a lot of customer engagements, doing a lot of education for Cloudera, talking, speaking engagements, this kind of stuff.
Grateful for this.
I'd love to do it. And I think I might be coming back a little bit more towards Spark in the near future, because I get tired of flying around and using my mouth.
And when you are contributing to Spark, what areas are you contributing to?
So the two main areas are Yarn and then statistics functionality in MLlib, with probably much more of an emphasis on Yarn. So I come from a Hadoop background. I'm committed on Yarn. So I've been doing a lot of the Yarn scheduling stuff. Right now, one of the big things I'm working on is reviewing a patch that will bring in the ability to do executor placement based on data locality preferences. And this has been something that's sort of been missing in Spark in a while, maybe a place where MapReduce still has differentiation. But this guy, Sai Shao at Intel, has thankfully taken this up, and we're trying to move that forward.
Oh, nice. I think that's great to hear, because I think data locality is really important for performance. I think it's very interesting that you're doing Yarn. So I think it's really kind of showcasing the kind of folks who can actually make real progress in Spark, because Yarn is a DevOpsy things, right? Like, how do you actually run this? Right. It's not obvious to any newcomer, because you usually start on Amazon. But any kind of production environment like Nitro, once the question is how do you actually run 24/7 with high availability, then you need something like Yarn or Mesos, right? And historically Spark was developed on Mesos. Actually, Mesos was the project Matei was working on, and Spark was a cute app demo, right? And suddenly kind of it reversed, and so Mesos was mostly used at Twitter, but now there is Mesosphere, and a lot of folks actually running Spark on Mesos. So, I'm probably more familiar with companies running Mesos such as Twitter and Sigmoid Analytics guys there. Basically, it's very easy to come into a shop and install Mesos, right? If you don't have the full CDH there already. So, I'm wondering, can you kind of emphasize or highlight the differences of
between
Yarn, Mesos, and why are you obviously by contributing to Yarn, then you bet on Yarn or you like Yarn. So how would somebody new pick between Yarn and Mesos?
It's a great question. In theory, they do the same thing. I personally wish that we could have just standardized on one of them. Mesos would have been fine, Yarn would have been fine. But as it ended up panning out, we have two of these. I think what has sort of ended up happening is that people who are trying to use clusters for scheduling a bunch of services have gravitated more towards Mesos, and Yarn has become more of a framework for high throughput data processing. So most of the people I talk to run Spark on Yarn. It could be because I'm in some sort of insulated Cloudera situation, but my hunch is that Spark gets run a little bit more on Yarn than it does on Mesos. I can talk about sort of the specific, cells for Yarn or cells for Mesos, but in theory, there are systems that do the same thing.
Okay.
I hope, I would like for us all to be able to pick one and move forward with it, but we may be just stuck with split-brain computation.
Can you talk a bit about Apache Myriad, which I think does some kind of interpretation of this?
So I actually have not heard of that. Is that something that allows you to run yarn on Mesos or something like that?
That's what I thought it does. But we don't have to talk about it.
Yeah, I mean, there have been quite a few proposals to run yarns out of Mesos or Mesos inside of yarn. It seems a little weird to me. Like within yarn, you're already doing two-level scheduling. You already have yarn doing scheduling and then Spark doing scheduling.
That's right.
Within yarn scheduling. So why another layer is needed? I'm not really sure. At least in the long term, maybe as a temporary solution.
Yes,
makes sense.
Yes, yeah, that was my question as well, right? Because obviously it's already the way to improve performance is to basically make the schedule kind of transparently, cooperatively, right, between different frameworks. So that kind of what my impression was. Interesting. So now it's definitely the kind of the golden age of Spark, right? So there is tremendous interest. We see IBM announcing Spark Technology Center right here on Market Street and get behind Spark in force. So this is a fantastic time. So in a way, some folks were saying maybe a couple years ago that Hadoop is going to go away, that it's actually going to be Spark. The Hadoop name is going to be there as a brand, but in fact it's going to be Spark is going to be big data. Do you agree with this?
I think it partly comes from there was this original conflation with Hadoop and Hadoop MapReduce. I 100% believe that MapReduce is going to go away. Who knows how soon. Spark has a lot of data to catch up, but ultimately MapReduce is going to be totally gone. I think Spark can satisfy all the use cases. I'm not convinced that the other parts of Hadoop are going to go away. I'm not convinced that HDFS is going to go away, or even if it gets replaced by some other file system, those Hadoop APIs are still the way of interacting. Of allowing the processing layer to interact with the storage layer, and then the resource management aspect, Yarn on top of that, and then of course there's the whole broader ecosystem, right? Kafka, Flume. Century, every sort of project. So of course those aren't technically Hadoop, but I wouldn't say that Spark has an extremely important role, but I wouldn't say that everything revolves around it.
Yes, and so we see, I think we see definitely everybody with lots of data using HDFS. So I think there is not really any other simple alternative to just create infinite storage and dump text files into it forever, right? Or Parquet or things like that. So, but we see a lot of places running now. Somebody came up with the term SMAC, which is Spark, Mesos, Akka, Cassandra, and Kafka. So it's kind of a new stack. I think that's if folks came up with this, and I thought there should be an extension called SMAC Hard, which is highly available, resilient. Distributed SMAC, right? Which is by default it is. So
all SMAC is hard.
That's right. That's very hard. So do you think that running Spark on top of Cassandra addresses most use cases? People do in industry, or it's still necessary in most cases to set up HDFS and basically the full system?
It's a good question. I mean, it depends what you're trying to optimize for. What Cassandra is great for is if you really want to have like random writes and reads. So both Cassandra and HBase as these NoSQL stores are optimized for huge data and then doing point lookups, that kind of stuff. If what you really care about is top performance for scans and doing batch data type of stuff, then I think HDFS is going to be what you want for a while. I mean, it's also a little bit less operationally complex to deal with a NoSQL database versus to deal with a file system.
Right.
I don't see Cassandra taking over, though there are certainly valid use cases for that stuff.
Right, and kind of I think that relates to another development. So we recently see Apache Flink entering the space of streaming systems, and today the second talk which we have is on Min Data, which is a Storm-like, very efficient streaming system. So these systems put streaming first and batch second,
Right.
and Flink makes this point that there's a whole continuum, and batch is just the limit version of a stream, right? So where we started with Storm, and then Spark was an initial batch but responded with mini batching.
Right.
Now we have Flink, which basically is doing streaming first and batch being the limit, right? So I wonder, right? You guys being Cloudera, essentially serving your customers, right? How do you see this space evolving? Do you see Spark and Flink kind of and similar systems co-evolving? Would, for instance, this kind of streaming first, batch second, batch first, streaming second dichotomy, is it kind of written in stone? Is it hard to change for Spark, for instance, or like for Flink to achieve the same batch performance, right? And I think it kind of relates to this HDFS setup, because the normal setup right now is just dump gigantic amount of stuff into HDFS, then read some subset of it in memory and Spark do batching, right? And kind of streaming comes after that. When you productionize, you put it into a streaming context. But essentially, it's in this batch model. So I think that's kind of why is it relevant to that?
Right. Yeah. I mean, so I think first of all, viewing this as a continuum is great, primarily because it allows you to have unified APIs for these two things. People have realized maybe even a while ago that if you can create platforms that make you able to use the same code for batch and stream processing. In terms of Spark versus Flink, so I would always say if you can, one system is better than two. So if it turns out that Spark can do everything that Flink can do, having that in the mix, is additional overhead. On the other hand, if it turns out that Flink there's a long way to go, I believe, in both Spark and Flink to be a full streaming system, whatever that means. So if Flink is somehow way faster at getting there than Spark, then I don't see any reason why we wouldn't, in CDH, let's say, include that in our platform.
Okay, and I guess my final question will be, of course, on Scala, because we are a big Scala shop. There's a huge overlap between SF Scala and SF Spark, and so Nitro uses Scala with Spark and almost everything else, including Play app and Akka. So
Sure.
That's correct. So and we have this big data Scala conference in August where we're emphasizing end-to-end data pipelines in Scala, right? So basically we say no ETL, we don't want to export and re-import and load, we want to keep it everything in very typeful manner and move objects around. So I wonder if you see this as a feasible vision in the industry. What's your experiences with Scala? Can we move enough data scientists from Python to Scala? What would it take? Where should we, a Scala community focus on making data science in Scala kind of the achievable goal?
Yeah, great question. So I first used Scala maybe a year and a half ago when I started working on Spark. I hadn't touched it before. Since then, I'm a total convert. I think it's the bee's knees, best thing ever. I would love for everyone to use Scala for everything. Whether that's a realistic goal, of course, is a whole another question. So I've started developing on top of Spark this time series library. Added a lot of statistics, functionality, and stuff to make it easy to do time series analysis on top of Spark, and so that I started building in Scala. And the hope there is that we can add a lot of the functionality that currently exists in, let's say, MATLAB or Python packages like stats models on top of Scala. So yeah, I would say that I'm a low-grade Scala evangelist. Though obviously Python and R have huge amounts of momentum for data science, and then Java has a huge amount of momentum just for data engineering stuff.
Yes.
So we'll see how things pan out in the next 5 to 10 years.
All right. Well, thank you very much. We're looking forward to your talk, and it's great to have you here.
Thanks very much, Alexy.
Cassandra.